Welcome to Know Thyself, a learning hub. Today, we are here with one more video regarding refraction. So, we'll learn what is refraction, what happens when a light ray passes through a glass slab, what is angle of incidence, what is angle of emergence, what is angle of refraction, what's an optically rarer medium, what's an optically denser medium, these things in this video. So let's dive into the video. What's refraction of light? Here, if you observe in this picture, you see the pencil appears weird. At the point of intersection or at the surface of water, you find a pencil like this, and in the water, you find the pencil bent. Why would this happen? What is the reason behind this? Of course, refraction of light. Now, what is this? It is nothing but bending of light. So why will it bend? How will it bend? In which direction will it bend? We'll see now. You see here, same with polar bear. Looks like its body is cut. And this is the peaks. Man sitting with a placard. Seems he is holding his head in his own hand. That is the reason. Yes, physics is fun. But it requires killer imagination. Now comes the question, how would this happen? How would the light bend? It's like this. Light bends when it enters a slower medium from a faster medium. Now, do we have any analogy or do we have any example? Yes, we have. If you're riding your bicycle at say around 15 to 20 kilometers per hour, on a smooth road, you're at full pace. You're at full pace. And suddenly there is a big sand spread. Your front wheel, which is already with the velocity of 50 to 20 kilometers, touches the surface of sand, and suddenly what happens? Your bicycle turns, slides, skids, turns. That is what happens with light. Of course, our velocity of bike is not even a match with the velocity of light. So that's an example. So when light enters from a thinner medium to a thicker medium, the velocity of light reduces and then light bends. The bending of light at the interface of two different media is called refraction of light. If the velocity of light in medium is more, then the medium is called optically rarer medium. If the velocity of light in medium is less, then the medium is called optically denser medium. So we have an example like air or vacuum is an example for optical rarer, and glass, oil, all these things are examples for denser. Now what is rarer, what is denser? This has nothing to do with the density, which is mass by volume. It has nothing to do with it. Now what is this optical dense? This means this medium can reduce the velocity of light. It is thick. So rarer is thinner. We can remember like that. So rarer, optically rarer is a thinner medium, and optically denser is a thicker medium. Now, light ray, as you see, with an angle, because if we draw a normal at the point of incidence, with an angle, if a light ray is incidented on a surface, what happens? According to the law that we have seen, or according to the example of bicycle we have seen, the ray bends. Now, is it towards the normal or away from the normal? That's the question here. Yes. If light ray is entering from a rarer medium to a denser medium, that is a thinner medium to a thicker medium, light bends towards the normal. And if a light is traveling out or emerging out from a thicker medium to a thinner medium, then the ray bends away from the normal. We have to remember this. And now, just like we have laws of reflection, we also have laws of refraction. What are they? The incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. This is a bit similar like laws of reflection. So, incident ray, the refracted ray, the normal, which is wrong, all of them, they lie in the same plane. Next, the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for the light of a given color. We have to underline that, for the light of a given color and for the given pair of media, because these may vary. This law is known as Snell's law of refraction, and we are going to look at this refractive index and Snell's law of refraction further in the further videos. So as of now, I am not touching that second law here. In the picture, if you observe, there is a normal drawn, light ray is incidented, the ray got bent towards normal, making an angle R. So the ray which is incidented, we know it, we call it as incident ray, and it makes an angle I, which is angle of incidence with the normal. And when the ray bends, we call it refracted ray, it makes an angle R, angle of refraction with the normal. So as I mentioned, if medium 2 is thicker than medium 1, that means if the ray of light is entering from a thinner medium or a rarer medium to denser medium, light ray bends towards the normal. Now we have to look, how does this refraction work through a glass slab, a rectangular glass slab. Here we can see it clearly. When the light is incident on a rectangular glass slab, it emerges out parallel to the incident ray and is laterally displaced. It moves from rarer to denser medium and then again to the rarer medium. Right. If you observe, the incident ray is incidented at an angle. If we draw a normal here, and as it is entering from the air to the glass slab is obviously thicker, so it's denser medium, so light ray bends towards the normal, and then without any interruption it travels, and now it has to come out from a thicker medium to the thinner medium, up to the air. So which is from thicker to thinner, and according to the law, if we draw a normal, it moved away. It moved away. Now, first suppose if we think refraction did not happen and light ray had propagated in a straight line, and now you project this light ray, the refracted ray, the emergent ray, back towards the incident. So now based on this, we observe, we can understand these both rays are parallel. That means, as it is mentioned here, the emergent ray is parallel to the incident ray. Now there is a displacement, there is a shift happen between the originally incident ray and the emerged ray. This difference, this distance or this displacement is known as lateral shift. When light ray is incidented directly from the normal, where angle of incidence is 0, light ray is traveling in the straight line without any deviation. Now if you observe, we changed the angle, it's making an angle of incidence which is I should be greater than 0, and we see the light ray bend towards the normal, and the emergent ray which is moving away from the normal, making an angle called angle of emergence. So angle of incidence, angle of refraction, angle of emergence. We have three angles, and the ray, we call it incident ray at the point of incidence. After refraction, we call it refracted ray, and after emerging out we call it emergent ray. So I hope you understood about refraction in a simple way. Regarding this, and I'm gonna make 2 more videos. One is the practical explanation of light ray passing through a glass slab and then prism. One more regarding refractive index, Snell's law. Thank you very much. Share and subscribe.